Hello everyone. So today in this lecture I just want to go through a combinatorial proof of binomial theorem. So binomial theorem says that for any positive integer, which is an integer, right? Okay, so anyway, so then x and y belongs to you can talk about in a complex numbers. Yeah, then x plus y raised n. So what is this becomes, right? So that is a question. I'm not going to write it the for explicitly, but we will find it, right? That is that we explore that. So before going to prove this particular theorem, I just want to consider a general product which involves some variables like this. So we are going to consider the product x1 plus y1 times x2 plus y2 going up to xn plus yn, and we will and what this product will look like. How can we expand this product? That is our initial observations, right? So let's observe a smaller case when n equal to some 2, right? So this product will be looking like x1 plus y1 and x2 plus y2. This will be, if you expand in a traditional fashion, you get it is x1 times x2 plus x1 times y2 plus y1 x1 plus y1 y2. Okay, so you got a sum actually involves 4 terms, right? And so you understand this expansion is a sum having the terms are products of length 2, right? So it's because we are only having 2 terms, 2 blocks. So that's why from each block one element will come, then the summand contain 2 terms. And also I want you to observe one important thing, because if you look at the summands, you can see that so it contains look at the index of these variables, right? Okay, so are you able to find x1 y1 in this, right? I'm really sorry, it is y1 x2, right? x1, right? So you are not able to, it is impossible to find x1 y1 here, because x1 y1 belongs to a single block. So x1 plus y1 is going to multiplied with the other block, so that x1 y1 cannot be present in the product as a term like this, right? So that is also you can't find x2 y2. Okay, that is also not possible, right? Then what we can observe basically, so let us go for one more step to understand this is clearly. So if I go for x1 y1 x2, I'll go for 3 terms, suppose y2 plus x3 y3. Then what is your idea? So it's also a sum. I mean, it contains a product of length 3, right? So for one of them I will write x2 x3 plus right, and maybe x1 y2 and y3, like that. It will come. So you can observe that it is impossible x1 y1 y2 is in this, because x1 y1 are coming from same block. And also notice that they are of length 3 because we have 3 products, right? Then I want you to observe a very important thing. Suppose our product xn plus yn, you understood that this is a sum of certain terms I call P. For example, these guys are I call P, right? So it's a summation P, right? So that product is how do it look like, right? So the idea is, suppose I have n elements, and definitely P is of length n. P is of length n, right? So P will be of some form like that, x1 and x2, suppose x3, right? Then it is very clear that y1 cannot be here, y2 cannot be here, y3 cannot be here. Why? Because then these fellows belongs to same block, so such product will not exist. So what's my claim is, suppose you assume n equal to 6, and the product will be look like this. If you have x1 x2 x3, then y1 y2 y3 won't come, right? So but you need right, so you need what is then it start from y4 y5 y6, right? So that's the way, because the length must be 6, because n equal to 6, and y1 y2 y3 cannot be come in the product, so definitely 4 5 6 is coming. So look at this. So 1 2 3 is a subset of 1 2 3 4 5 6. Okay, so when you choose these index 1 2 3 for x values, then the 4 5 6 is completely the complement of that. Suppose I assume a is equal to 1 2 3, then a complement is 4 5 6, right? So if you choose an index for x variables, then the completely opposite index will be in the next side. So basically, my assertion is, I mean, what is the product is of the form, the product of xi's, where I belongs to A, which is a subset of n. So maybe you can, n is nothing but 1 to n. Okay, and this is multiplied by the product by yi, where I belongs to a complement. So that is also going to be the subset of that. So choosing A determines the product, a particular term. So our product xi plus, I mean, xi yi, I going from, I mean, I is from this one. Okay, so right, So I can't just, I should not say okay, so we don't have power raised to n, so this is our product we are looking at. So this product we are looking, right, x1 y1 times x2 y2. So I say that this is the summation a subset of n, right? I can say p, so or I would say like product I belongs to a xi multiplied by pi I belongs to a complement yi. So this is the idea. So each subset you choose, it will happen. Okay, so that is that is the complete summation, right? Yeah. Now I can split this. So I'll just call this particular product term as PA because it depends on A, right? So this is equal to A subset of n PA, right? Now this PA, I have not restricted A to be, so this A can be cardinality from going from 0 1 2 because phi is a subset of A and the full set is a subset of A. So I can make a double sum, that is k going from 0 to n summation cardinality of A is equal to k PA, right? So the idea is you have suppose x1 x2, then y3 y4 is one product having this, and you may have x1 y1 y2 y3. This is also a product because, right, I mean x1 y1 will not come, it should be some y4. So there are many of them will come with as a PA, right, with cardinality, same cardinality. So so how many, so now you choose xi equal to x and yi equal to y. I mean, you, for every variable xi you put x, for every variable yi you put y. Then what happens is this will be look like this: k equal to 0 to n summation k, because all of the terms are xi's are x and all, so this product will be a singleton x raised to k times y raised to n minus k, right? Now how many of them are like that? So that is very simple. How many subsets A such that cardinality k can be choose from n elements? So that is equal to nck. So this would be equal to k equal to 0 to n nck x raised to k y raised to n minus k. Okay, so I will illustrate this using an example. So you try to find out x1 plus y1 and x2 plus y2 and x3 plus y3. So this product will look like this: x1 x2 x3 x1 x2 y3 and x1 x3 and you have y2 because It has to be completely opposite. So, and x1 you have y2 y3, x2 you have y1 y3, x3 you have y1 y2, right? So I have 6 terms, right? 1 2 3. I need more terms, I think so. Plus, what is missing? How many? Right. What is missing for just one? y1 x1 x2 y2 x3 x1 y3 is already there. y2 x1 x3, that's also there. 1 2 3. Okay, we have y1 y2 y3, so yeah, 8 terms, right? So look at this. I mean, so in this particular case you have, so here what is your set? A is a subset of capital 3, I mean the 1 to 3. So this is 1 go up to 1 to 3. So in this case A is just 1 2, so the complement was just 3. That is in the, okay, this A is not, A is 1 2 3, so the complement is empty, so no problem. Here right, okay, so this is 1 2 3, A is 1 2 3, so there is no problem. In this case A is 1 2, so the complement is just 3, so that happened in index of y. Here A is 1 3, the complement is 2, happened in this. Now in this case I put x1 equal to x2 equal to x3 equal to x, and y1 equal to y2 equal to y3 equal to y. So what happens is, first one is x cube, second one is x square y, third one is x square y again, then x y square xy square plus xy square plus y x square plus y cube. So how many x square y is there? There are 3 x square y and 3 xy square. Yeah, 3x square y and 3xy. So that means it is x cube plus 3xy square plus 3yx square plus y cube. So that is the formula, right? So this is the way it comes. So our product is, so choosing the subsets of 3 determines the complete product. So that's why it says NCK. So I think you understood the a major portion of the binomial. So the binomial theorem tells you that x plus y raised to n equal to k equal to 0 to n summation nck x raised to k y raised to n minus k. So this is a one combinatorial proof. Okay, thank you.